the DOS and the DOS prevention. So there have two files, DOS and the DOS prevention. I'll just show you both. First, what is denial of service, and then I'll just tell you both. Okay, now let me upload the files. Now this is whether I already have a SOL file, you can upload it here directly. You need not copy paste or create a file, just you can upload. So upload, and you can use DOS and DOS prevent both. You can see here the DOS and DOS prevent both got uploaded. Okay. So now what I do is now actually this is DOS. Okay, first we go with the mitigation. Okay. Now see that the goal of king of ether is to become the king by sending more ether than the previous king. Previous king will be refunded with the amount of ether he sent. Okay, so what does it mean is there is one king called as king of Ethereum. He wanted to become the king by sending more ether than the previous king. So there is already one king. So if I send more ether, then I will become a king. And the previous king will be refunded with the amount of ether he sent. Whatever he sent will be refunded to him. So this is one goal. Now here in this case, they deploy the king of ether. Okay, Alice becomes the king by sending one ether to claim throne. So we have a function called as claiming the throne. Claiming the throne means I will be the king. I am just going to claim it. Now Bob, which is the second guy, who just sending two ethers to claim the throne. Okay, so he is sending two ethers. So first Alice is sending one ether and Bob is sending two ethers. Alice received a refund of one ether because Alice now is no longer a king because he sent only one ether Ethereum, whereas Bob sent two Ethereum. So Bob became a king. So Alice key will be returned to him back. I mean his Ethereum will be returned to him back. Now deploy attack with the address of king of ether. Now what happens is now an attacker node which is to deploy the address of the king of ether. So we have to capture the king of ether address and then we have to deploy. Call attack with the three ethers. Now what is a call attack with three ether mean? Because already the claim throne is with the two ethers. Now I send three ethers to get the give the attack. So current king is the attack contract and no one can become the new. So now the attacker will be the current king and he get a contract and no one can become the new king. Even giving 4 ethers or 5 ethers more than what the previous king gave. The reason being he come with the address of the king of ether, the attacker. So attack to give the king, all new challenge to claim the throne will be rejected since attack contract does not have a fallback function. So he don't have a fallback or a receive function. So because of that, the contract gets validated. See, if a old king wanted to become a new king, he has to give more money. Suppose a new king giving more money, he become a king. So old king will be refunded back, right? But the attacker code doesn't have a refund option. In that case, what happened? The money won't be refunded. So the attacker become the indefinite king. This is what it means. So denying. So now this is the king of ether. So now see the contract name is king of ether, Ethereum. So we have an address public key and the balance. Okay, so claim throne is external payable and need to pay more to become the king. So this is what here the balance we need to pay more to become the king. And this is the value here failed to send ether. In case if you don't have a balance, then I can say that failed to send the ether Ethereum. Then attacker comes here. So he has an object here with the king of ether. So this attack what it will do is the publicly payable king of ether claim throne value message dot value. Now there is no option to go back. That means there is not a single task to view back to the king. King of ether. So the attacker once he become a king, he is the permanent king because there is no refund option. So whoever comes next, there is no refund option. So he becomes the king. Okay. Now this is one. First I will run this. After that I will let you know how this is happening. Okay. Now this is the king of ether and deploy. Okay, so king of ether is deployed. So claim throne balance king. Okay, now copy this. Now go to the attacker, attack, control V and deploy. So the attacker also deployed. So there are both of things have deployed. So balance is 0 ETH. Here the claim the throne balance king. Okay. Now first thing is we have so many so many ethers we consumed. So now I'll go with the one person with 100 ether. 5c6. He is the one, the king, trying to be the king. Now he is sending 2 ethers. 2 ethers he wanted to send and claim the throne. Okay. So now 2 ethers he is sending. See the king. Who is the king? He is 05c6. Okay. So he is the king because we have sent who is the king is 05c6. Okay. Now his Ethereum is reduced to this much. Okay. Now what I do is I want to make some other to be the claiming the now balance. You can check the balance is 2 Ethereums because he sent 2. Now one more person is coming. No, the person, the first one, he wanted to come with uh, 1 Ethereum. So let me show you 1 Ethereum and claim the throne. He could not because more Ethereums only it will be claimed. So now again he will come with the 3 Ethereums. Now 3 Ethereums and claiming the throne. Now 3 Ethereums, balance is 3. Now who is the king? The king is changed now. Okay, so 5b38 he's changed now. The king gets changed now. Who is the king? He is a 5b3. That guy is the king. Okay, so now the balance is 3 Ethereum because he paid more. Now let the attacker comes into the picture. Now attack. Now attacker comes with 1 Ethereum. For example, attacker, let the attacker be someone else from 100 Ether. 0A0. 0A0. He is an attacker. He comes with 1 Ethereum. Need to pay more to become the king. So already the king is 3 Ethereums. So he need to pay more. So let him pay 4. So 4, let's say 4 to become the king and 0A0. Okay. So now let's see the attacker. He became the king now. Now see the king here. 3B4. So claim throne. So it is 4 here. Oh, 0A0. Here it is 0A0. From this amount, the money is being sent. So the attacker becomes the king here. Okay, now let me see if anybody else. Let's say I give 5 now. So if somebody is giving 5, and let's say he wanted to become claim the throne. Now, which is not possible. You can see someone is trying to give 5 Ethereums or 7 Ethereums. Let's say somebody want to give 7 Ethereums. 7 Ethereums. This guy wanted to give and try to claim the thing. It is not possible because the particular attacker became the king and he is not allowing anybody else to get the claim the throne. So this is called the denial of service. So this means this contract become a option there. Nobody can able to claim the contract because one attacker is sitting there denying the service of a contract, a smart contract. So this is where happened at the denial of service. Now how to prevent this? Now this is where we have one code called as preventing here. DOS preventing. Now the DOS preventing here, this is how the way it happens. Current king cannot withdraw. Okay, so withdraw public is there and we update the balances there and claiming the throne. External payable no need to pay more to become the king. So the balances is been checked here. The balance in the king is checked here and withdraw function is there. So the attacker code is no longer can able to claim the claim the throne. Okay, now I'll be showing you that as well. Compile it. Now let me delete the contract here. And here we have king of ether. Deploy. Now once it is deployed, we have this this the key. Okay, so now claim the throne. Now you have to send some money. 1 ether, claim the throne. So he just claimed who is the king. The king is 0CA. Then the 147 he sent let's say 3. Claim the throne. Now the balance is there 1 plus 3 will be 4 ETH. But earlier case it was not happened because it comes with the new set of ETH. The old Ethereum will have become 0, but now it become 4 here. Now who is the king? The king is changed. Now check the balance. How much Ethereum is balance? It is 4 only, but total balance here is 4 Ethereum, and it is. And withdraw also. The king of Ethereum cannot withdraw because we have to give the addresses over here. So the address of a particular method we have to use it. So let's say give the copy address of any address. It is 0 here. So that means that the fellow has not given anything, and this is the king here. Now, this is how the way I can able to claim the throne without any attacker to, return. So we have a function called as withdraw public. So withdraw the money from the king. Current king cannot withdraw. So if you have a current king, you cannot withdraw any money. But the king, if others can able to withdraw the money. So in case we want to send also, the failure to send the ether, if you have a balance less, you cannot send the ether to anybody else. So if the sender is having 0, if the value is 0, they cannot send the money to other account or send the ethers to other account. So this way we can able to avoid the or prevent the denial of service attack. So generally the attacker code, the main problem with the attacker code is the attacker comes with a attack function to claim the throne with the message value. Here this is how the attacker will do. So it is a separate contract there. The attacker simply comes with a contract. Okay, so in this contract, when two contracts are talking to each other, the king of ether, once he just get the complete contract, he prohibits in the other contracts to deposit the money. So this is the main problem in the attacker node. Okay, so denial of service is very common in many of the applications where the money will be there. Nobody can able to touch that contract, and it's completely forbidden by any other contract to read the values or downloading the money or whatever. So because of a particular attacker node who goes inside, block all the money and claims all the contracts to its discretion by prohibiting the other contracts to get into it. So this is the denial of service, which is very common in this blockchains.